All right, guys, so I kind of switched back to Swivel because I think it has better quality and I miss Swivel and he's been at my house, but I haven't even used him. So I think I'm going to record with him and we're going to go to 10-5 and we're going to look at areas of complex figures. So we've done areas of parallelograms, triangles, trapezoids, and circles, and now we're going to make the figures more complex. And so we had to look at the basic figures in order to be able to figure out these more complex figures, especially dealing with area. One announcement, guys, if you're listening to this, we have a quiz. I changed it to a quiz on Thursday over 10-2 to 10-5, today's lesson. And then we're going to finish chapter 10 after Easter break. So again, it's changed to a quiz, not a test. And it's only over chapter 10 and lessons 2 to 5. Okay, so today we're going to be looking at figures such as this one. And this one's a little bit complicated. It actually has a story problem to it. It's a sketch of like a attic room that they want to see whether they need to get paint for it and how much paint they need for that room. And so they're going to give you some dimensions here. And there's a lot more to this problem than it looks like. I'm just going to give you the numbers. We're dealing with feet, but I'm going to put the numbers just not to make it too complicated with this. So this is what they're giving me on this problem. And then they give me a diameter. Okay. All right, so I believe this is all the info they gave me. Now, they want me to find the area of this figure. So if I'm looking at it, it's not a simple polygon that we've looked at before, and there's a lot more information given to me. A couple things I want to note. When you're looking at area in this lesson, and you'll have a few problems to do after this, but the lengths of a segment, so like this bottom segment, I know that the length is 20 because that 20 is right in the middle of that segment. You see this segment right here? 3 is the length of that one. This segment right here, 3 is in the middle, so it's the diameter, not the radius, which is half. And then here, the height of the whole figure is 11, and you can see kind of like they're trying to show you that. So side lengths are given in the middle, except for a few exceptions. It's pretty much always that. Okay, there are really two ways to work this out. One way I had to realize is that, and by the way, this problem, this part, so everything is shaded, and everything is shaded except for the little circle in the middle, the window, and it says find the area of the shaded portion. So this is where it can be a little bit more complex if we're looking at this figure. So everything here is shaded. I know it's kind of hard to see, but except for that little circle, which is the window of that room. Okay, so what we're going to do is we're going to break this figure into parts so that we can find the area of each. And there are really two ways you can figure it out. I think some of you see, and I'm actually going to use a different colored marker to kind of help us out with this. But some of you see that this figure can be broken down into... Do you guys see this rectangle down here? This rectangle right here? And then this is a triangle. And then this is a circle. So if I break it down into simpler shapes, I can take each one of those shapes and either add them together or subtract them depending on what I'm looking for. Okay, here's a little formula I need for this particular problem. The area of the shaded portion, so area of the shaded, so A sub shaded, is equal to, and this is something we need to get, the area of the triangle, right? You have to get the area of the whole triangle plus the area of the rectangle. So getting the area of this rectangle, and then that amount minus the area of the circle. Area of the circle. So that's what we're working at. So we're actually finding 3 separate areas and adding 2 of them and subtracting a third. Again, this is one way of doing it, and I'll show you not the whole way of another of doing it, but maybe another thought some of you could have had with dividing this figure. Okay, so first we're going to find the area of the triangle, and remember to find the area of the triangle, that formula is 1/2 base times height. So you got to remember that one, 1/2 base times height. Okay, so here's the triangle, right? I'm highlighting here with my marker. This is my triangle. Okay, what is the base of the triangle? What's this length? Well, if you look at its parallel side down here, this is 20. That must be 20. So right now I have area equals 1/2 20. And then I have to find the height. Now, it's very dangerous if you just write the numbers that are given to you and think that's going to be the height. On this height of this triangle, do you notice that it's from here to here? So the height of the triangle is right here to here, right? They didn't give me any of those measurements. They gave me a 3 here, gave me 11 there, a 3 right there. Look at it here, guys. From here to up top is all 11. But I don't want this little portion here. So what's 11 minus 3? It's going to give me my height of that triangle. From the top to the base of the triangle is going to be 8. So that's going to be my height. So I'm going to multiply these 3 together to get my area of the triangle. So I'll do it like this. What's 1/2 of 20? It's 10. What's 10 times 8? 80. And I think you guys can see this. So I have 80 for the first part. The area of the triangle is 80 square feet. And we'll get that square feet at the very end. Okay, how do I find the area of a rectangle? So this bottom rectangle right here, this bottom rectangle. Remember the formula for the area of a rectangle is length times width. Okay, length times width. Or technically it's just base times height, which is the same thing. All right, what's the length of the rectangle? The length of the rectangle is 20. What's the width of the triangle or the rectangle? It's 3. And I just have to multiply those 2 together and I get 60. So I get 60 for the rectangle right here. So right now I have 60 plus 80. Okay, I have the if I didn't have the circle I was looking for, I could find the area of both shapes just adding those up. But the circle is unshaded, which means I have to subtract that amount. So first of all, what is 80 plus 60? It's 140. So that's not the total, that's not the final answer. That's the area of everything combined. But I want to take away the area of the circle because that's not part of the shaded portion. So how do you find the area of a circle? The area of a circle is, if you guys got to memorize this by Thursday, pi r squared. Pi r squared. And this one, the calculation is a little bit tougher because of the number they give you. But here, all right, pi is always going to be 3.14. And then I have to find the radius and then square that. Okay, remember, this circle right here has a diameter of 3. So I'm not going to put 3 into that formula because I don't want the diameter. I want the radius. So the radius is half of 3, which is 1.5. 1.5. And then I have to square that. So I'm going to do that calculation up here. So 1.5 times 1.5, because that's what 1.5 squared means. It means that number times itself. So here, 25, 75, 0, 5, 1. Then I get 5, 12, 2, 25, but then the decimal point goes there between the 2 and the 2. All right, so that's just 1.5 squared. I have to take 2.25 and multiply it by 3.14, and I'm going to do that here. So 2.25, that's my magic number. So 3.14 times 2.25. So here's the longest calculation you're going to have to do. And we're not going to take the full answer. We're going to round that part and then subtract that from 140. So here, we'll just work this out. 20, 70, 15, 15. I gotta be careful here. 6, 8, 16, 8, 10, and then decimal point goes 4 over, so 7.06. We'll say 7.1. So 7.1, we'll round it to the 10th. Okay, the area of the circle is 7.1. So what do we do between those two numbers? Well, remember, the 80 area for this whole shape and the 60, the area of this whole shape, is what it is all together. So I added those together. But then I have to take the area of the circle, which we got was 7.1, and subtract these two right here. So I'm going to do 140 minus, and be careful how you arrange this, 7.1. So line up the decimal points. I'm going to borrow from the 4. So I got 9 point, and I got 2, a 3, and a 1. I got 132, and we're talking about feet, so square feet. Okay, so 132.9 square feet. All right, that's a big problem, right? You had to find 3 separate areas. You had to add 2 of them and subtract the third, but that's how you find the area of these complex figures. You have to break it down into its parts. And that's one example. Now, I'm not giving you a ton of problems here, but I do want you to be ready to do these complex figures. Okay, now I'm going to go to the next example. Some of them, by the way, are easier than others. So like this one's fairly complicated, but then you have some other ones that pop up. And I've officially broken into my blue marker. So here, they're going to give you a square, and then this is the hard part for me at least. Okay, then they're going to give you a circle inside, and they're just going to give you 14, I'll put the unit 14 centimeters. And the shaded part is everything but the circle. Everything but the circle. Okay? So they want you to find the area of the shaded portion here. On this one, I want to find the area, and I think it says it is a square. Okay? So this is a square, and then obviously inside it's a circle. So I want to find the area of the square, and then I want to subtract the area of the circle. So the area of the shaded part, so this is what I'm trying to find, the area of the shaded equals the area of the square minus the area of the circle. So that's what I'm going to be working. I want to get the area of the shaded part. In order to do that, I take the area of the square and I subtract the area of the circle. Okay, how do you find the area of a square? Area of a square has its own measurement. It's basically area equals side squared. You can also say length times width, but what do you know about a square and its length and width? They're both the same. So if this is 14 centimeters, so is this, right? So is that one and that one. So we know what all side lengths are. So we're going to go ahead and do that. The area equals 14 squared. Okay, so let's do 14 times 14 because that's what it means. So 16, 56, 0, 4, 1, 6, 9, 1. Okay, 196. So I get the area of the whole. So if we just had a square, like nothing was unshaded, we shaded everything in there, we would get an area of 196. But we don't want everything. We want everything except the circle. So now we're going to have to find the area of a circle, which, how do you find the area of a circle? Since we did it in the last problem, pi r squared. Okay, so same formula as we did in the last problem. So here, pi is 3.14. Okay, this next part, the radius, you got to be careful again. You're like, they didn't even give me the diameter. How do I know what the circle is across going through the center? You're like, I mean, I don't know. Okay, they gave you 14, didn't they? So if I had a point there, what would be the distance across that circle? It would be 14 as well, right? Because these two measurements are the same. So I have the diameter being 14, but what's the radius? So what's half of that? Well, half of that is 7. What do I have to do with that 7? I have to square it. So I have 3.14 times 7 squared. I have to do 7 squared first, which that one's an easy one. But 3.14 times 49. I'm going to do 3.14 times 49, and I'll do that over here. 3.14 times 49. So 36. Almost blanked out on that one. 28, 0, 16, 5, 12. 6, 8, 13, 5, 1. Decimal point goes 2 over. So 153.86. 153, no decimal between the 5 and the 3. 0.86, we're going to go 153.9. 153.9. Okay, what do I have to do with this area and that area? If I want to find only the shaded portion, I subtract them. So I'm going to do 196 minus 153.9. Again, lining up the decimal points. And then borrowing when I need to. 1, 2, 4. So I get 42.1. And we're talking about centimeters. Excuse me. So I sneezed right into that mic. But square centimeters. That is the area of the shaded portion. 42.1 square centimeters. So that one wasn't too bad, but that's what you're going to be doing. Okay? I'm going to run to the next example because, and I still have to go back to that first one and show you how you could have done it a different way. Actually, you know what? On that last problem, I said I was going to show you a different way. I'm sorry, I missed that out. I want you guys to see if you can think of another way to break that last example with the triangle and the rectangle. See if you can break it apart in a different way. I just gave you a hint. Okay, here's the next one. This one's a little bit tougher, but I hope you can understand what's going on. Okay, so we have that. Oh, I think I did well there because I don't usually draw these very well. I'm just going to give you the numbers. I'm not going to put the units because I don't want to bog this diagram down. But do you notice that my numbers are in the middle of the segment? So I know that this segment right here is worth 4. This one's worth 3. They didn't tell me what that one was. That's okay, but I'm trying to draw those as accurately as I can. But then they also gave me some designations here, and then they did something for me very nicely. They did that as well. Okay, and they gave me one last number right here, 4, which is exactly what I need. Okay, it's not perfect, but it'll do. Make sure I get everything here. Okay, one way to do this, kind of how we were talking about, is to split it into different figures. So maybe some of you are thinking, oh, I guess I kind of see it. And this is hard. I'm not going to do it this way. But what if I split, what kind of shape is this right here? So just right here, if I was highlighting this one, wouldn't that, 1, 2, 3, 4, 5, that'd be a pentagon. And if I broke it down again, I'd have like a little square and a trapezoid. Right here would be another square. Right here would be another rectangle maybe. And then a trapezoid. So I'd have like 6 figures or 5 figures I'd have to combine. Another way of looking at it is, look, what if I completed this figure, across the top? So I'm trying to draw like a dotted line up here. What if I called this a big rectangle? I mean, isn't it that what it is, a big giant rectangle? And if I found the area of the rectangle, that would give me a little bit too much because I don't want this part right here, right? But do you see what this shape is inside on the top? That looks like a trapezoid. So in this problem, this is what I'm going to work out. So to find the area of what I want, so I can even put area of wanted. It doesn't matter how you designate it, just you make it clear what I want. I'm going to take the area of a rectangle and I'm going to subtract the area of a trapezoid. Okay, again, I could have said area of a I think this is a rectangle, a trapezoid, a square, a rectangle, and another trapezoid. I could have done that and combined them all together, but this looks like a lot easier for me. What would be the area of this rectangle? Well, first, what's the formula for a rectangle? It is length times width. Okay, L times W. All right, what's the length? 18. What's the width? 8. Okay, that's not too bad. I'm going to multiply those out. 18 times 8, 64, 144. So I got the area of the rectangle being 144. Okay, that's the area of the whole thing. Like if this was one big rectangle, I would find that area. But do I want the whole thing? No, I don't want this part. Like I don't want this. I want that eliminated or subtracted. So this case is like I want the area of the unshaded part, right? Because you could say either way. So this is a trapezoid. All right, this is what they give me. They give me 4. Okay, I know that's one of the bases, right? Which reminds me, what's the formula of a trapezoid? It's 1/2 base 1 plus base 2 times the height. Okay, so there's a lot going on in that trapezoid. Okay, I have one of the bases, it's 4. I mean, do I know what this is up here? What the second base is? I mean, I know that from here to here is 18, right? The whole way across. And then this should be 18 altogether. But then I have these two little portions of 3. Why don't I do 18 minus 6? 3 plus 3 is 6, so 18 minus 6. That would leave me with 12. This second base is 12. How do I know? What's 3 plus 12? 15 plus 3 again, 18. And that matches up with down here. Okay, but I still need to know the height, right? This perpendicular height that I don't have. I know that from here to here is 8. And from here, right, to here is 4. So what would that make this? Another 4. So I got a 4 height, a 4 base, 12 second base. And I'm using that based on what they've already given to me. So here, we're going to have 1/2 times the first base. I called it 4. It could have been 12, but it doesn't matter which one you call first and second. And then the height is 4. Okay, so I'm going to do 4 plus 12. That's 16. And you could do 1/2 times 16, or 1/2 of 16 is 8. 8 times 4, 32. So the area of that trapezoid is 32. What do I do with these two shapes? I do 144 minus 32. 144 minus 32. Remember, 144 is the whole area. 32 is this little area. I want everything but the little portion. So I subtract 2, 1, 1. And so I get my area of 112. And in this case, it was square centimeters. That's how I find the area of that complex figure. Sometimes you divide it into simpler shapes. Sometimes you can complete a shape and then subtract the remaining part up there. So that's another way of doing that one. That's one way of doing that one. Okay, I think I want to go through semi-complex one. I mean, these aren't, I can't go through every single one of them, but you have to know all of the formulas that I've mentioned up to this point. So if you don't know these formulas, you have them in your notes. But if you don't memorize them by Thursday, you're going to be stuck in the water on these because these can get very complex. So let me give you one example of what they want you to do on this one. Okay, and then they did... Okay. They gave me 12, 9, 6. 9 and 6. Okay. There's nothing shaded. They want me to find the area of this complex figure. And you're like, what is it? I mean, it looks like the top of a truck almost. I don't know. But I would say this. Okay, can you identify the simpler shapes that make this one up? Okay, I think I see a rectangle and part of a circle. Now, my diagram isn't the greatest, but on these homework problems, If they look like they're part of a circle, they're going to be what we call a semicircle or half a circle. So this is only half of a circle. Okay, that's half of a circle. Okay, so if I want to find the area of the whole shape, so I'll say area of complex figure. So complex. I have to find the area of the rectangle. And what do I do with that semicircle? Should I add it to the area of the rectangle? Should I subtract it from the area of a rectangle? Well, isn't it the rectangle with the semicircle attached? So it's going to be an addition problem, the area of the semicircle, which, remember, semicircle is going to be half a circle, exactly half a circle. And that's important for this problem. All right, area of a rectangle, because I've beaten this down so many times. Area of a rectangle, length times width. Length times width. What's the length? They didn't tell me here. Oh, wait, it's 12. What's the width? It's that 9. 9 times 12 is 108. So that was a nice one, right? The area of the rectangle was very nice, 108. But then the semicircle, right? That's the tough part. Okay, the area of a semicircle. And I'm going to do it like this. It equals, well, we know what a circle is, pi r squared, right? Pi r squared. So if you have an entire circle, pi r squared. But I only want half because it's a semicircle. So why don't I find half of that? Right? That's where I get the half from. I want to find half of the circle. So if the whole circle is pi r squared, half of it is 1/2 times that. So this would be the more complicated figure. So here I have 1/2 times 3.14 times, okay, we got to find that radius. Now, do you see how that 6 is in the middle? What's the radius? It's from the center to the circle, so it's only half of the diameter. So the radius here is 3. So I have to take 3 squared. So be careful. Again, I'm probably going to see on your homework 6 squared, and it's going to be a bigger number. It's going to come out wrong. You gave me too much. So what's 3 squared? Because you have to do that first. That's 9. So I have 1/2 times 3.14 times 9. Okay, and you can multiply these in any order. Some of you could see, oh wait, 1/2 times 9 is only 4.5. Then multiply by 3.14. That's totally up to you. But I'm going to do 3.14 times 9. 3.14 times 9. 36, 12, 27, 28, decimal point. All right, I got 12.26. That's these two multiplied together. But I still have to multiply by 1/2. Remember, multiplying by 1/2 is the same thing as dividing by 2. So I'm going to take this 28.26 and I'm going to divide by 2. Think of it this way. If I have the area of the whole circle, which is 28.26, how do I find only half of it? I can divide that area by 2, and that'll give me the half circle. So 1, 4, 1, 3. Okay, so I got 14.13. 14.13. What do I do with these two numbers if I'm finding the area of this complex figure? I'm going to add them. 108 plus 14.13. Making sure that I line up decimal points. So I get 3, 1, 12, 2, 1. Decimal point. I get 122.13. And then this problem gave me meters. So square meters. Okay? Now, be careful on these problems, guys. Some are going to be easier than others. And I will be available at, I believe for you guys, it's 1 o'clock for any kind of questions that you may have. Check it up on Google Classroom if you have any questions on these problems. All right, take care, guys. Bye.